This is actually a revision to the video I posted yesterday, which I've now since taken down because I've made some changes to it. And the fact that somebody reported it as inappropriate content. Keep that up, guys, and you'll see more and more stuff that you won't see because it's going to go Patreon only if people keep reporting stuff to YouTube as being inappropriate. So you guys can choose whether you want to see it or not. But anyway, let's look at the revision here. I made a few changes. Let's take a look at this. Okay, in this video, we're going to compare two LEDs. These are dollar store special. You can see the price. I got this at Dollarama. This is $3. Both of these bulbs are $3. And one came from the dollar store with more, and the other one came from Dollarama. Now the difference between the two of them, this is a 9 watt, equivalent to a 60 watt bulb. And this one here features 750 lumens. This one here is a 450 lumen, and it's a 6 watt bulb, and equivalent to a 40 watt light bulb. So this one here looks to be a little bit more efficient because it only uses 3 more watts, and it's got 300 more lumens. But anyway, what we're going to do on this is we're going to open these lights up. We'll put them on the watt meter and see if they really are drawing the power that they claim. And then we're going to take them apart and we're going to take a look at how well these ones are constructed. So here's the bulb. It appears to be a plastic lens on here. Let me just grab the light socket now and we'll plug it in. As we can see, it lights up instantly. It's got a nice even light all the way around. Not like some of the old ones which had hot spots and so forth on them. And if we look on the power meter, we actually see that it is drawing about 4 watts. Let me just check the voltage here. And okay, we're running at 117.5. So we're going to put this at exactly 120 volts. It's important to show I can dim. If I turn the voltage down, as you can see, the light actually does not dim because these are non-dimmable. And I can take the voltage right down. Let's just see where it finally goes out. Down at 70 volts, 60 volts. Okay, it's starting to dim just a little tiny bit now. And then it goes right out. So it kicks in around 40 volts. Even though it's a non-dimmable light, as you can see, it can dim slightly, but not by much. We'll take it up to 120. There we go. Exactly 120 volts. And now we'll look at our power consumption. And as you can see, the power consumption is actually only 4 watts, not 6 watts as it claims. Well, as you see, it gives off about the equivalent of a 40 watt light bulb. Not a lot of light. If I pan the camera around the shop here, as you can see, it's not very bright in here with this light. But it is equivalent to about a 40 watt light bulb. So for this test, I've set the camera on manual expose, and I've set the iris on manual iris, and we're going to just put a regular, this is a 40 watt bulb. We'll put a 40 watt incandescent bulb in here so that we can see if it is any brighter or any dimmer. So there's a 40 watt incandescent bulb. So we can look at the light level here on my workbench, and then I'll go back and I'll put the 6 watt. As you can see, this bulb here is also drawing, it's actually showing it's only drawing 30 watts. It's also, oh wait a minute, it's a 130 volt rated bulb. So of course it's not going to draw 40 watts when it's only running at 120 volts. If I crank the voltage up here to 130, this thing will get brighter, but it should also show that I'm drawing 40 watts. So we'll turn the power up. This one should be a 40 watter. We'll see. This one's actually measuring 34 watts. But as you can see the brightness of this one. Look at the brightness on the wall, look at the brightness on the package here, and then we're going to go back to the LED. The LED is brighter for sure. No question about that. Okay, so now that we've seen the LED compared to an incandescent bulb. Let's crack this one open. Little power meter actually has more features on it. It even tells me the voltage, 120.24 volts. If I go through the menu, the light is drawing 0.08 amps. That's 60 hertz. Power factor is terrible. It's only a 0.5. But most of them you can pop the top off these things because they just snap them together, right? Just like that. Okay, so this is what we've got in this one. Looks like it's just plugged onto a power supply too. This is the the positive and the negative. You can actually measure the voltage coming out of the power supply there. There are lights. We put the meter on here. This will be DC. So let's just measure the voltage that is being fed to the LEDs. Looks to be 45.28 volts. So that would be 9 volts per chip. So inside each of these little chips, these are all going to be wired in series, and there's going to be 3 LEDs in series on this. Let's open up the die here. And take a look at what's under the die. What does it say on here? It says suitable for damp locations, not for use in totally enclosed luminaries, not for use with dimmers. And that's all it says there. Damp locations, that's why this is sealed, but I don't see it completely sealed. I don't see any silicone here. So I'm going to put it outside, but it's going to be in an overhead fixture, so it's not going to be getting wet. So I just want to cut through the silicone here because I want to lift the die out. I want to take a look at the heat sink, and I want to take a look at the see what type of power supply they're using. Are they just using a capacitor dropper, or does this actually have a real power supply in it? I'm going to say this probably has an inverter of some type in here, and there it is. So it does have an inverter, and we have to remember which one's the positive. Good thing I've got video. The positive is the one on the left here. I can't take this inverter board out there, or can I? I don't think I can. I think it's actually soldered down to the base here. Or is it plugged? Maybe it has a plug. Let's just see if this will unplug. No, it's not going to unplug. It's actually soldered down, so I don't want to damage that thing. It's soldered down to the base. I may have already buggered it up. Let's just see if it still works. I may end up having to take this thing apart. No, it still works. So the power supply on this unit is it's got a fuse in the bottom, I can see. I can't get the power supply out without doing some serious damage. I guess maybe if I put some heat on it, I might be able to unsolder it. But down in the bottom here, if you look, you'll see that there's a small fuse, little red thing down the bottom. So it does have protection. See the little red fuse right down in here, and that's going to the tip for hot. Looks like we've got on here, we've got a couple of electrolytics. There's an inductor and a couple of electrolytics, and it looks like there's a little IC down here. If we look in the bottom here, we've got a bridge rectifier, we've got a little IC, a diode here to rectify it, and there's a couple capacitors, and there's a little inductor here. So that's basically that for this one. We'll take a look at the other one next and see how, if it's any different. I think it's probably going to be exactly the same layout as this one though, because it's the same brand. It's a Luminus, right? It's just a different type of bulb. One of them is called the Basics. This one here is the Basics, and this one here just says Luminous LED warm white 2700. So they're both rated at 10,000 hours. Just one's 9 watts and the other one is 6 watts. And I'm curious as to whether the actual power supply is the same in both. It's got to be different, but you never know. It might be the same power supply and just more chips on this one, but it's got to be different. Anyway, let's open the other one up. So here's the other one. We'll put that in here and try it too. This one's drawing 7 watts, as you can see here. Let's take a look at our power factor. It's probably no better. Our power factor is actually 0.58, between 53 and 58. So the power factor correction is a little bit better on this one. And it's drawing between 7 and 8 watts, and it's rated at 9 watts, this one. So let's just pop this one apart, and we'll take a look at the build on this one. It pops apart exactly the same as the other one. Okay, different design. This one's got 5. This one's got 10 chips in it, so it's a totally different die. It's much smaller too. If you look at the difference here, here's the 6 watt with the 5 chips in it, and the 9 watt it has 10. So it's got twice as many LEDs. So if we look at this one, open. The chips are pretty bright, and that one's actually, it is quite a bit brighter. I mean, just looking at it to the eye, it's noticeably brighter. Let's just check the voltage out on this one and see what type of voltage we're feeding the chips on this. I can't even see the terminals to. I'm looking at this and I can't see the terminals to measure. Oh, voltage is a little higher than that. Let's go to the 600 volt range, and we are seeing that this one's being fed about 87 volts. So if we do the math, 10 LEDs, 87 volts, 86.9. So just under 9 volts, 8 volts per chip. Okay, and this one actually, if this one's actually getting warm, the base, and just the time it ran there, that base is actually warming up a bit. And I'm now seeing stars from looking at these stupid LEDs. Let's remove the circuit board on this one and take a look at the build quality of this one. See what we can see in the base. Oh, well, this is much better. You notice that they've actually, this one's mounted on a metal base. That's why this is heating up. Because this comes loose here. I wonder if I can actually, you know what? I bet if I undo these wires, I'll be able to take this thing apart. Let me just turn on my iron here, and we'll remove the 2 wires here, and I'll just mark them so that I know which ones go where. My marking pen here somewhere. Can't see anything, I'm still seeing stars. We'll mark this one as the white wire and the gray wire. I'm going to take this thing apart because you can see that the base actually comes apart on this one, which is different than the other one. And, well, I kind of buggered that up when I took it apart, didn't I? Nothing that super glue won't fix. Okay, let's unsolder the chip die here. Wires still don't want to let go. It's just lead-free crap. This lead-free solder is hard stuff to work with. You got to get your iron really hot. In order to do anything. And the fact that this thing's mounted on a heatsink is makes it a little more difficult to do this too. I don't want to damage the LEDs because I'd like to use this light. Okay, we have the die disconnected. As you can see, they've got some thermal paste. Not enough, I don't think, but they've got some thermal paste on there. Maybe we'll put a little bit more on this thing when I put it back together. But there's our die. I'll just put that out of the way for now. I want to lift this apart. So here's our circuit board, and it looks to be the same type of board that was in the other one. It looks identical actually. Obviously the voltage is going to be a little bit different, but the circuit board itself looks the same. Maybe it is the same, maybe it's just the load of the LEDs that determine what the voltage is, but it looks to be a similar board to the other one, so not really much to see here. But it does have a nice heat sink in here to cool, you know, and this metal goes all the way around here, so it is going to keep this LED a little bit cooler than the other one. We'll put that back together. I'm going to put the die back on here, and we'll put the screws in before I. Oh, let's get some more thermal paste in there. We'll get a little bit more thermal paste. After all, I would like this thing to last a few years. We're asking a lot, right? We're asking a lot if we expect these LEDs to last more than a couple years. They're never going to last what they claim. At least none of the ones that I've had so far have gotten anywhere near the rated number of hours. And I've got several around my house. And I've had a number of them that have burned out. A number of them that have burned out when back in the day when they cost, you know, $20 and up. Now you can get them for, you know, well, these were $3. $3 each. That's pretty good. I'm not going to complain if these only last, you know, 2 or 3 years at $3. Who would complain, right? But when they were $20, yeah, that was a, you know, tough pill to swallow when they burned out as quick as they did. Okay, that's one gray wire down. Get the white wire down here. See if it still works. And it does. So there we have it. Let's put this thing back together somewhat. This one actually just has little tabs. They actually put this together and turn it. There's a little feet, and they put some glue on it. This one here, you can see it would have been pushed together and turned, and they just put some glue on there to hold it in place. So that's how that one went together, and now it's just a twist off top. I'm not going to bother putting glue. Well, maybe I will, but let's put the other one back together. This one here, it just pops together. Good to go. We'll compare them in the dark, and I'll compare the other one to a 60-watt bulb. Let's turn out the lights again. Okay, there's the back of my workbench. As you can see, that's with the 6-watt bulb. And yes, it is considerably brighter to the eye. And we can compare this to a frosted 60 watt bulb. And there's a 60 watt, a Sunbeam 60 watt. And you know what? It's not as bright. It's definitely not as bright as the LED. There's the 60 watt incandescent, and here's the 9 watt LED. That is definitely brighter than the incandescent. I bought a bunch of these incandescent bulbs for my kid when he had his lizard. He had a gecko, and we used them as a heat lamp. So I bought a pack of 4 of these for $2. You can still buy them, as I say. You can still buy these things for people that really like the incandescent bulb. Anyway, that's a quick look at a couple of Luminous LED lights. Dollar store special, $3. I say 2 thumbs up. These look good, and the build quality of them looks pretty good. I guess time will tell how long they actually last, but this one here is going to go, this 4 watt one is going to go, so 4 watt? 6 watt. 6 watt. But it only draws 4. This one's going to go over my front door to replace the last one that burned out. The Lights of America. The one with all the little individual chips that failed. Well, I fixed it once, and now another one's popped on it, so this is going to go out in place of that light. Here's something interesting. So the 9 watt is rated at 750 lumens, but if you look at, and that's why I say the 60 watt bulb, well, it'll give out 550 on 130 volts, but on 120 volts, which is where we were using it, it's only going to draw 54 watts. It'll last 7,500 hours, the incandescent bulb. So this thing's going to last almost as long as the LED, which is rated at 10,000. But look at the output. It's only going to put out 433 lumens running at 120 volts. So 433 lumens versus 750. That's why it was so dim. These incandescent bulbs that you can still find, they're all rated for 130 volts. So, you know, they will last longer for sure. Because you see, the only incandescent bulbs that they're allowed to sell here in Canada anyway, and I'm sure in the States as well, is they can sell rough surface bulbs, you know, with rugged filaments to withstand rough handling and shock. They can't sell household bulbs anymore. They've phased them out, they've banned them, but they can sell rough service. And the rough service bulbs are like for use in things like garage door openers and ceiling fans and stuff where there's a lot of vibration. And they can still get away with selling them, but they put out considerably less light because of them being rated for 130 volts. So there you go. Anyway, I thought that was kind of interesting. Looking at these 40 watt ones, right? These 40 watt bulbs, which were rated at 120 volts, 310 lumens for 40 watts, 54 lumens, only 433. So they're not that bright, the old incandescent. These are really bright. So let's just take a look here at the heat sink here, because as you'll see, I already got somebody commented about it not having a large enough heat sink. So I just want to show you something here. That this is actually metal. The whole base of the lamp here, as you can see, I wanted to do it on camera so that because, you know, some people, if you don't actually show them what you're doing, they don't believe you. This entire base is metal on here. This is the heat sink for this lamp. So for those that are worried that this thing's not, see, I already scratched it, so I knew that, but I just wanted to show you guys in an updated version. Plus the fact that someone reported my video as inappropriate, and that brings up another point. If you guys want to continue to see free videos, stop reporting my videos to YouTube as being a harmful or inappropriate video. YouTube's already reached out to me to tell me that it is not a bot that is identifying my video. So if it's not a bot, it's a viewer. So since I released a couple Patreon videos in the last couple of days, my Patreon membership has gone way up. If you guys want to see more free videos, stop being idiots and allow my videos to play with their commercials. Otherwise, there will be fewer and fewer public videos and there will be more Patreon-only videos. That's all I have to say about that.